Welcome to the demo video for our paper titled, Extreme Scale Talking Face Video Upsampling with Audiovisual Priors. Our researchers have always been fascinated with questions that push the limits of computer vision. From recognizing objects in 30x30 images to detecting faces in a 3x3 image, the field has progressed leaps and bounds. In this work, we investigate the problem of upsampling extremely low-resolution talking face videos by large-scale factors. Though this is a highly challenging task, we present a novel neural network to generate highly realistic talking face videos generated from extremely low-resolution versions using the right set of priors. Talking face videos are often accompanied by speech that is in sync with the speaker's lip movements. Speech can provide us with identity characteristics like gender and age and essential information about the lip movements of the speaker. We thus decide to use this as our first prior. We also realize that the identity characteristics are heavily lost in an 8x8 video. While there has been no work on talking face video super resolution, standalone face images have been super resolved by completely hallucinating the identity characteristics. This leads to changes in head pose and even the speaker's identity when handling higher scale factors like 32x or 64x. On the other hand, we decide to use a single higher resolution image as an additional prior for generating the higher resolution video. Let us look at a high-level overview of our method. We consider the low-resolution frames and the corresponding audio signal as our inputs and give them to the visual and the audio encoders. We fuse the encoded representations and pass them to the identity structure and motion predictor module, consisting of iterative upsampling and downsampling blocks. The backbone network aims to recover the elemental facial attributes, including the identity, face structure, pose, and motion information. These intermediate outputs act as driving video to our end-to-end trainable animation network, which ingests a single high-resolution image of the target identity as input and animates the identity image according to the motion of the driving video. The final output from our network is a realistic, high-quality 256x256 dimensional talking face video 32 times upsampled from a mere 8x8 video. We train our network using a host of other losses like the sync loss using a lip sync discriminator, and landmark-based region loss to improve the quality of our generations. Please refer to our paper for more information about the losses and training procedure. We now move on to the comparisons and show more results from our method. Since we don't have any comparable works, we modify SparNet and Techogen for talking face video super resolution. We add a higher resolution reference frame by concatenating it channel-wise with the lower resolution input video in both the networks. This is done to maintain parity with our network. We also modify SparNet appropriately to ingest a temporal input. Techogen, being a video SR paper, does not require this modification. All the models were trained for 32x super resolution.
Problemas sin preocuparnos por las dependencias, por el sistema operativo que se encuentra debajo y demás.
Can be replicated in existing institutions. I think there should be more value placed.
Our method performs far better than comparable methods. Our task also shares similarities with audio-driven talking face generation, A2TF, and face reenactment, FR, tasks. Although our task resembles in terms of the problem space, it is to be noted that the focus of our work is very different, upsampling very low-resolution videos. Nevertheless, we show a comparison with these works below.
With the sense that they experienced something that was very much Disney, but very much felt like theirs, very much felt like home.
The A2TF methods, Wave 2 Lip and Make It Talk, generate talking faces using the audio segment and a single target identity image. For FR methods like FOMM, since we do not have access to the original HD video, we use Techogen to upsample the LR input along with a single HD image of the target identity and audio segment. The A2TF and FR methods fail to accurately match the pose of the original identity, whereas our model generates consistent and noticeably better results and also preserves the pose of the identity to the maximum extent. We show some more results from our network.
Million people in the UK, so it's quite likely you have patients under your care affected by one. There are over 6,000 rare diseases, each of them affecting just a tiny number of people, most of them children, and we're finding more every week.
Auf den ersten Blick in die Firmenstruktur nicht erkennbar, aber auf den zweiten Blick merkt man dann, dass ein paar wenige Personen eigentlich alles in der Hand haben.
Reconocimiento, pero en realidad lo que están mostrando son jóvenes que se suicidaron simplemente por no querer recibir sangre.
Those days, I don't know if it's still the case, if you're doing maths and further maths, you did your maths A-level a year early, which meant I had already got maths A-level under my belt, and I could drop the further maths and have lots of free periods to do TV presenting.
Sunt stănilor din comuna Corbi Mare, satul Ungureni, Născut în anul 1923, 16 iulie.
Questioners, what they ask you. So in the last debate, they asked me about things in New Jersey.
Change in how Australians relate to me as an individual.
Our method works for any target identity image, either from the same video or any other image, with similar characteristics in terms of the face identity, pose, clothing, and background. Here is an example of a target identity image from a different video.
Then I realized we're about inside the 35, so I knew that.
One of the main applications of our work is in compressing talking face videos to extremely compact representations, which can lead to serious bandwidth savings. Our network makes it possible to transmit only 8x8 talking face video frames across the network and generate the 256x256 versions in the receiver's end. To further improve compression, we train a frame interpolation network at the 8x8 scale. This network consists of a simple 3D CNN-based encoder-decoder architecture that can convert a 5 fps video into a 25 fps one, allowing us to send only 1 in 5 low resolution frames from the sender to the receiver. The receiver can then use frame interpolation to create a 25 fps, 8x8 videos, which are then upsampled to the full resolution of 256x256 using the upsampling network. We also observe that even after combining the frame interpolation network and the upsampling network generates realistic talking heads matching the original ground truth. More details about the compression characteristics are present in the main paper. We also report several additional experiments and ablations in a supplementary PDF document submitted with this video. Please refer to this document for more insights into the model. We will release the codes and models to aid future research. To ensure fair usage, we will have agreements with the users of our codebase to abide by the ethical concerns.